Good day, everyone. Welcome to another edition. This is the 2022 Festive Tech Calendar. I've been doing this for multiple years. Always happy to see Bit on his toboggan. And if I look outside, it's dark now here in Canada, but we've got a lot of snow. We had about 75 centimeters the other day. So this is a reality for me. So I live in the countryside, a lot of green trees like what Bit is seeing here. So really excited today to talk to you about something quite specific. We'll be looking at RESTler, a REST API fuzzing tool. Maybe you'll want to add this as your new AppSec security control later on. It's a REST API fuzzer. It's stateful. It's something that should be added to your chain. But perhaps you're new to fuzzing. Perhaps you're new to stateful REST API fuzzing. But today we'll go ahead and demystify some of these in a nutshell because this is a lightning talk. So looking forward to having this small journey with you. My name is Joël Hébert and a grand pleasure to be with you today. So first of all, I always start with a quick audience poll, and since I'm talking in a video here, you can do a small introspection and sort of be pensive with regards to these questions. So what tools do you use to secure your APIs? Are you doing any specific types of scans? Are you checking the composition of those APIs, the perimeter security? What is it that you're doing today? What type of threat landscape do you have around those APIs? This is something that you should be questioning yourself on and perhaps learning to do the art of attacking yourself, effective defenses. We always say the best defense is a great offense, but if you're not going on the offensive against yourself, how can you effectively defend? That's what I'm kind of getting to at. So how many of you today listening at this video are actively fuzzing your endpoints and remediating issues? So are you utilizing fuzzing? You may be utilizing other techniques, but was fuzzing omitted because you've never done it before? What would be the reason for this? But usually it's people don't understand fuzzing, have never crossed it, or the teams are not enforcing it. Those are some of the elements that have led to people not fuzzing. I'll tell you how this talk came to be and it's why, for you to have a comprehension. So as I was working in the API landscape and with different API programs, I was utilizing SAS, so static code analysis, effectively opening up the code, looking at it, ensuring that it is secure, going through doing passes through that code with different tooling, usually stacking one paid, one free, in case you lose some of the funding, doing dynamic or DAST type of scanning from the perimeter into the app, the way that it is meant to be utilized, scanning it and ensuring that it is secure, looking for different vulnerabilities and different gotchas. Once again, one free, one paid. Pretty standard in the industry to stack both of these techniques together. Lastly, the software composition analysis. We know that we are constructing software like building blocks and Lego building blocks almost, where we are assembling a whole bunch of them. Definitely we want to take a look at those to see if somebody has injected vulnerabilities inside of different packages or whatnot. We want to go inside, take a look, remediate, report, look at compliance issues. So usually you kind of see these as part of most programs, SAS, DAS, and SCA, but fuzzing was omitted. Did not have full comprehension of what fuzzing was. I knew it had to do with injecting a whole bunch of data values to break things, but did not comprehend of what type of bugs you're hunting for. So if I take a look at SAS, DAS, SCA, and fuzzing, we could say that DAS will look for some of the OWASP top 10. SAS definitely will look for SQL injection, cross-site scripting, cannibalization issues. Fuzzing will probably, in this scenario with RESTful API fuzzing, and definitely RESTful API fuzzing that is stateful, will be hunting for 500 level errors. Some other scenarios that you'll see later on, but you're actually looking for a different class of bug and different type of elements to oversee compared to the other type of scanners. So it's time to discover fuzzing. So let's go ahead and do a mini deep dive. So like I said, the OWASP top 10 looks at certain very direct elements: broken access control, injection, insecure design. While you can definitely find some of these with fuzzing, you're not necessarily going to be looking for cross-site scripting directly or XXE or anything of the sort. We're not bug hunting for these kind of things here. What we'll be looking for is crashing the RESTful API with a 500 level error. It can be a 200 as well, or we'll look at some examples later, but definitely we want to crash the site and then sort of take a look at what's going on behind the scenes. So it's a little bit different. So I just wanted to put it out there. If you take a look at the MITRE ATT&CK framework, where does this sit? The large landscape overview that is MITRE ATT&CK. It sits in developed capabilities under exploits. And that's really interesting here. And do take time to peruse this area and take a look. Adversaries may use information acquired via vulnerabilities to focus exploit development efforts. As part of the exploit development process, adversaries may uncover exploitable vulnerabilities through methods such as fuzzing and patch analysis. So there you have it. Not necessarily looking for just your regular vulnerabilities, but you're looking for something that can be exploitable later on, perhaps leading to a denial of service, perhaps leading to remote code execution in some cases, perhaps leading to resource leaks and whatnot. Here I took a article here from Synopsys, and it's the actual integration of fuzzing to DevSecOps. I showed you a bunch of different tooling from SAS, DAS, SCA. Those are injected in the DevSecOps tool chain and also the ordering of things in different areas. So just wanted to put it out there that as you delve into fuzzing, where would this go here? Well, as you can see here in the green square, fuzzing all externally exposed protocols and traffics. It's after you deploy it here while you are testing in your dev environment, definitely to fuzz. As you'll see in a lot of the documentation, fuzzing a production endpoint is not recommended, and actually you should not be doing this. Definitely something that you don't want to do. It's going to inject quite a bit of data, utilizing the endpoints as they should be utilized, creating, deleting, doing other things. While there are flags that you can utilize to get away from some of the pred endpoints, the generation of traffic can be so large that it will come and affect your production instances. So definitely at dev, you can go ahead and find these vulnerabilities and scan in your dev environment that is restricted for this type of testing here. If you wish to visualize fuzzing, so here we have, I took RESTler, fired it in its full mode, and you can kind of see here that it's taking an endpoint and firing different values. So if you take a look, we'll just sort of zoom in here. The query string parameter here, page and per page, is getting a whole bunch of different values injected, essentially trying to break the page. So we're going from, string literals, numeric literals, combination of string and numerical values. We're adding decimals, anything to try to break the site. So definitely, if you take a scanner like a OAS Zap, you'll get a similar feel and it'll start firing executions. I'll kind of explain while you're fuzzing what is a stateful fuzzer. How does that fuzzer take a look at the API specification and then infer some of the different patterns that are the producer-consumer? What do I need to fire in order to have that continuation and do that inference? What are the patterns that I am utilizing when I'm firing against that API endpoint that don't make any sense, so I don't repeat them later on and lead to excess traffic? So definitely, as you're going to be fuzzing, you're going to be seeing a lot of traffic similar to this. But what is very important with stateful fuzzing is that inferred consumer-producer logic that is essentially what makes it stateful. And then the secondary part is it can comprehend what patterns don't make sense when there are failed executions and not repeat them later on. So let's just take a minute here and take a look at OAS Zap and take a look at like one way that was traditionally done. You can definitely take OAS Zap and take an open API spec and fire against it. But just at its most basic rendition, if you take OAS Zap and just fire it not in a non-stateful manner, not analyzing the open API spec, definitely you can take an address. So in this one, I just did an active scan against this area here, localhost API blog post, which is the API that we'll be utilizing today. So we'll talk about it just quickly here. I have an API running It's right here on a Docker container. And we're just going to fire some executions. I'll talk more about that later on. So if I go here on the left-hand side, you can see a whole bunch of executions that have occurred, right? So if you can take a look here, right, you're trying to find some different elements. So there's everything here from canonicalization that I'm seeing. You'll probably be seeing things related to SQL injection with some unions here. If I go to attack and fuzz over here, definitely you can go ahead and take some different parameters and inject some different values. Yes, you can take from files and inject larger things, but just to give you an example, here somebody has to actually come in and do different types of units of work, and then you could basically start the fuzzer and then replace these values, start executing against your payload. What you kind of want is not to do any of this type of work and sort of cast a wide net. If you have some specific use cases, this can be very effective. There are other suites that do things like this. Burp Suite is one of them. Fantastic tool for doing not only REST API security testing, but web application testing as well. But this is just something here in its most rudimentary form, just to show you, not stateful, not utilizing an open API spec. It is possible to just fuzz a single endpoint that went through an active scan and that you wish to switch the values. You may have a simple password list that you want to inject. This could be username, password, fire across, or perhaps different values here. So you're fuzzing. You could take a lot of not mischievous, but out of bound values here to try to break this. Here we're getting a 422 unprocessable entity, but you're looking for that 500 server error. That's what we're looking for effectively today. So on that, let's take a look at the main element for today. So we're going to introduce RESTlers. So this is stateful REST API fuzzing. So let's talk a little bit about this. So the first and foremost, before getting into the tool, definitely we want to show you where it resides and talk a little bit about it. So let's go here. So you notice that it's on GitHub. Yes, so it is open source. So it's from Microsoft, RESTler Fuzzer. And the first thing I always do is I take a look at a project and I want to see when the last elements were added, right? So we're seeing 3 weeks ago, 4 months ago, 2 years ago, 4 days ago, and you're seeing that there's some fixes here 4 days ago with a large number of commits. So healthy project, definitely fun to see. So now that you know where it resides, that it's a healthy project, you can see that it's described in different peer reviews here. So there's documentation if you wish to read more about stateful REST API fuzzing, security properties of cloud services, because you're definitely going to want to take those REST APIs and fire against cloud services, whether you are the producer of cloud services or you're just creating your own RESTful APIs. Differential regression testing for REST APIs and intelligent REST API data fuzzing. So all these articles are extremely fun to read. So not a very difficult read. Sometimes papers can be very cumbersome or a little bit too technical for the average person. Similar to myself, I don't have a science background, but I found that while reading those, I was able to follow along and comprehend. So that to me is very important when reading some of those papers. So what exactly is RESTler? So in a nutshell, so without reading all those docs or doing any YouTube videos, it's a stateful REST API fuzzing tool for automatically testing cloud services. So basically, the REST API usually is tied to an open API spec. By looking at that open API spec, you have a full description of the API, and then you can fire some executions against it, which brings us to the next point. It can infer producer-consumer dependencies. So perfect. If you have a whole bunch of different calls in your API, and there are producer-consumer dependencies, those ones can be inferred, and then those will be represented in the different type of requests that are going across. So in this example, we have a request B should be executed after request A because B takes an input as resource ID X produced by A. So definitely it understands the hierarchy and the inference. So it will bake that into the sort of these Python libraries that it has for execution of the different elements. So you're not just scanning one endpoint and fuzzing it. it has comprehension that you have to do things in a certain order to get certain results, right? So this becomes fun when you want to look for resource leaks. So you fire something, delete it, go verify if that exists, or create something under that, and something allows you to do so. Did you really delete the resource? Was it queued, even though you told it that it is deleted? Can open up quite a few scenarios. The next thing that makes this quite interesting is it analyzes dynamic feedback from responses. So here they say that learning that a request C after a request sequence A and B is refused by the service will avoid this combination in the future. So things that are problematic will be avoided in the future. If something is refused by the service, no sense in continuously firing against that endpoint. So in a nutshell, let's take a look here. So if you take a look at the example, so you take your Open API spec, so this will be describing my API. The fuzzer will then do a compilation and create what is called a grammar fragment. So this is Python. It's going to take that Python file, and then effectively after that, send a bunch of sample requests. So what does this look like? So you grab your Swagger spec, basically do a compilation. That's going to be giving you what is called a grammar file. We'll look at it when we do the tests. And then after that, the RESTler test engine is going to execute, and you can test and find those bugs. So it's as simple as that, but quite a powerful tool. So today what we're going to do is look at the demo blog server. So this is part of some of the tooling that you get when you go to the RESTler page. So if we go here, notice that there is a demo server. You can also get a Docker container that you can run. That's what I've opted to do. And before we move further, I'd like for you to take a look here. So I've got a folder called RESTler. So I've downloaded. You can download the code directly from GitHub and do a compilation. And what you'll need is two things basically. So in my case, this was a new machine. So .NET SDK and Python, because the code is actually in Python, so you'll need that to do the compilation and then the execution. I tested out a few different APIs to run against. So I tested Vampy, a vulnerable API, some other renditions, but I thought that this one actually brought out a lot more anomalies than maybe Vampy. So Vampy is a vulnerable API, but it probably has more vulnerabilities in the realm of like a OWASP top 10, where if I ran a static code analysis against it or dynamic code analysis, I'd probably find quite a bit of things. But we're looking for things that can at times be part of a sequence. And essentially, I didn't think that made a great demo for what I was utilizing. So once you do compile everything, you're going to end up with a bin and an area called RESTler. In this area here, as you're going through the different stages from compilation to test. I can't really see test here, but yeah, so I'll just pop it over to testing, the full fuzz, and then the lean fuzz. So we'll talk about that in just a second. All of the elements will be placed there. So essentially, yeah, you can just download, compile, and then after that, go ahead and use the command line against it, and away you go. So if I go back to my slides here, today we're going to use the Open API demo blog. So let's take a look at what this looks like. So this is running locally, so on 8888, and this is just the demo blog server that comes with the tooling so that you can test and then activate some key scenarios for you. So basically we've got just a few different endpoints. We've got one called post, so that's got a get and a post. Sorry, then we have get blog posts as well. So we've got a get all scenario, get single, put single, delete everything. You can create a post, and then just the get the API doc, so you can get the specification. We have a series of different schemas here, so nothing complicated, right? So it's the nomenclature to the pathing is API, blog, posts, and then here basically, right, you're getting all of the posts Here you're just getting a single one and updating certain ones, deleting certain ones. So quite simplistic in design, easy to set up. It's on the OpenAPI Spec 3. That's it. So it's just basically running locally, and then we can hit it with different executions. So what does that look like? Sure, let's take a look. So first and foremost, we start with the first stage, which is compilation. So what we want to do is take that OpenAPI spec. We're going to ingest it as part of our first process, and we're going to generate a grammar fragment. So what does that look like? We're going to go to the command line, and on my machine, we're basically going to run this command. So let's go ahead and do that. So I'm just going to clear the screen here, and if I go to compilation, here's a simple one. So we're going to tell RESTler, so it's command line tool. We're going to tell it what the path is to that OpenAPI spec. So this is swagger.json. It's under demo server test. I downloaded it and put it there. I pressed start. It's going to start compiling. Doesn't take very long, so it's going to collect the logs, and away we go. So now if I go to this compile folder, I'll be able to go in and peruse. Perfect. So now inside of this area, I should have a grammar file amongst other things. So let me just open this. As you can see. Perfect. So what do we see here? We see that we have a Python file, and inside the Python file, what do we have? Evidently, we have a request, a get, right? We have some of the pathing over here, some static strings that are getting added here for some of the host headers, a way to inject the token, whatnot. It has done its passes, and it's basically constructing a grammar file over here, which will be used later on as a base to fire execution. So there is a log here of what's going on. That's launching the .NET process. It's compiling. If there's any errors, it'll show up in the std errors, and then std out is going to explain everything that it did, right? So it's doing some passes for the different endpoints here. So it's discovering, doing the passes, and assembling that element. So the pre-processed area, this is something that I very much like, is it keeps the sort of like the last element that it processed. So here you'll have the OpenAPI spec, demo blog server. So if you ever wonder what was compiled, you can kind of go in there. So I think that is fantastic. So that's kind of like the first step. And like I said, we're taking an OpenAPI spec. We're taking that Swagger sample and then creating a grammar fragment, sort of like that stage one, going straight from a Swagger JSON, and then we're generating a RESTler grammar. Perfect. So that is now complete. Second phase is doing a smoke test. We're quickly going to execute all of the endpoints that we have. We saw we had approximately 6 of them there. And we want to make sure that what we have as a compiled grammar, when we do executions, there's no issues. Can I actually get to the endpoint? Is there authentication problems? Is there problems with the way that the grammar was formulated? It can be quite a few different things, but it's going to just do a smoke test against those endpoints to make sure that they can execute. What does that look like? Very similar to the last execution. We're going to take RESTler.exe test, pass it a grammar file, which is the file that we generated, right? So it's called grammar.py. After that, there's a dictionary file, dict.json, and then after that, a engine settings, right? So if you want to tweak the engine itself, you can definitely go in here and change it. We'll talk about that today. Here I've opted with no SSL because I'm just running this locally. There's no SSL. The dictionary, definitely you can inject certain ranges and different values to utilize and sort of like fine-tune, as I should say. That's your fine-tune adjustment. Same with the engine settings. But for this test and just fireside chat today, we're just going to go ahead and do this execution. So what does this look like? Let me go back here. And now what we're going to do is run the test, and this is going to execute. And what did we see here? So we're seeing it's going to cover 6 out of 6 of the calls. It attempted the request, no bugs were found. So it was able to execute a few different tests, approximately 6 of them. They were able to get to their destinations and come back with a value that was expected. and now the smoke screen is done. Very good here. When you don't want to start fuzzing everything when the endpoints are not fully attainable, or there are authentication or pathing issues through different appliances across. So next step, stage 3, is what is called a fuzzling. So essentially this is going to execute once for every endpoint method in the RESTler grammar with the default set of checkers and check if the bugs can be found quickly. So it's not going to do a very long fuzz like the next fuzz, which is stage 4, which can be lengthy. This one takes just a few minutes approximately. In my scenario with 6, I think it's about 800 different calls when I intercepted it with my proxy. So what we're going to do here, and I want you to peek, the command changes to fuzzling, but it's still similar, right? It's the grammar file, once again, the dictionary, and the settings file with no SSL. So some similarities. So what we'll do here is no longer we're going into a fuzzling mode. We're going to execute this. So now we'll wait just a minute or two, and as this runs and it's going to give me some elements here, I'm just going to go ahead and for time's sake move into the last one, which is the actual full fuzz. But essentially we won't be running this today because it will take longer than the presentation. So this would be doing that full fuzz. Definitely not running this against a production workload. Stay very clear of that. For the dev environment only. Let's go back. Could be complete. Yes. So now it's complete. So now it's actually found a few things. So what it did is it tried to do 6 out of those 6 calls. It did find bugs. What did it find? It found a class of bug that is in the 200 OK range, or 201 created. It found 2 of them. So not necessarily a 500 level error. But these are using these built-in checkers that it has. There's an invalid value checker, so definitely we're hunting for those 500 invalid server errors used after free. And then it said that it succeeded. So now what we can do is essentially go and take a look at what was produced. So if I go back to my RESTler area, and if I go into my, one second here, RESTler. Fuzzling. Perfect. So if I go into the fuzzling, let's go into the results, and it's called an experiment. Definitely want to go one right here. Perfect. So we have the bug buckets here, and if I go ahead and let's just open up a new notepad, you'll see my different elements here that were created inside of the command line. So I've got invalid value checker 500. So we'll just take a look at one of them here. This is called a use after free checker. So it's going to look if something can be utilized after it was freed, right? So if you take a look here, there was a post. This post here came back with an HTTP 201 created. So evidently something was created, ID of 43, my first blog post. After that, there is a command to delete. There's a max awaiting time here of looks like 20 milliseconds. Definitely it comes back and tells you no content, right? So 204. And then after the fact, we're going and getting the blog post 143, correct? So 143. And there's a 200 OK. So essentially capable of grabbing something after it was freed. Definitely something to take a look at. Not necessarily a 500 level error, but something that one person should peruse. If we go here and take a look at the invalid value checker, this one's a little bit different. This one, there's an injection of a bad value. Here we're doing the page per page. We saw that in some of the examples, firing very large values to see if we can break the application. The application broke with a 500 internal server error. Definitely we want to capture that and then peruse what is going on in the application behind the scenes. So that is another one of these default default checkers that comes with the tooling. So I would really suggest to peruse them. You can look at them and learn a bit more about them. But the type of bugs that are detected with RESTler and what I would think with a RESTful API fuzzer. 500 internal server errors, anything that's directed by the main driver here. But then this RESTler tool comes with these checkers, right? So we saw the use after free checker detects that a deleted resource can still is still being accessed after its deletion, right? There's some resource hierarchy checker. If a child resource can be accessed from a non-parent, there's leakage rules checkers. There's a series of other checkers here. So you can see it's actually hunting for a different class of bug than that traditional OWASP top 10. So a couple of examples here. Why would you fix a 500 internal server error? Backend corruptions, resource leaks. So you kind of see, quick example here, you've got a service that takes in an input. That input gets parsed, it gets passed in, right? And then, the first allocation works, second, third one doesn't. What happens to these two allocations here? So what you've got essentially is resources A and B are leaking. That's what's going on behind the scenes. That is problematic here in your API, right? This is if it's throwing a 500 server level error, you're not catching it correctly, you're not deallocating the resources. One of the elements is use after free violation. We kind of saw one in the example. Creating a new object of type order. I go delete that order. I create an object underneath that order object, and then I get a 500 internal server error, but I didn't get a 404 not found. I did not handle this correctly. What is going on in the back end? Am I leaking resources? Is there something that could be orphaned? Or essentially, should I remediate this and send back a 404 not found and handle it properly? Because that object should not exist, right? A resource hierarchy violation. Here's a good example. Sending two messages. So I got blog posts. I'm sending one to 1250, one to 4400. And then I reply to the 1250 with 3534. And then I actually go ahead on this side and on 4400 and point towards the 3534, and then this is allowed. Absolutely not. It should be a 404 not found. So at times there are resource hierarchy violations. So it can go ahead and take a look at this class of bug here. Another one is a resource leakage violation. So go ahead and create a new object with a bad body. So we saw something that had a bad query string. There's also executions that will just do this in the JSON of the body when you do a post, and then you get an internal server error. You go ahead and get a list of all the objects. The return list is empty. Your object is not in there. And then after that, you recreate a new object with the same name but a different parameter, and then you get a 409 conflict. You now have an inconsistent service state. This is problematic. You need to go back into the code and rework some of this backend here. Lastly, how do you integrate this inside of your CI/CD tool chain? Because it's a nice tool, you probably see the benefits. You want to use it as part of your CI/CD tool chain. So for your REST API fuzz testing, there is the RAF project. This is now, let's just click on it. It is now repository has been archived by the owner before November 8th. It's now read-only. So this was a REST API fuzzing service, and I very much like what it says here. Thank you for the usage of the RAF fuzzing as a service platform. I learned quite a bit of things here. The thing that I really liked about this REST API fuzzing as a platform service is you could bring your own fuzzer like RESTler, Zap, Dread, Schemathesis, because the RESTler does something in a certain way, Zap does something in a certain way, Dread does something in a certain way. You can actually stack them and run them one after each other. And then after that, take a look at like the job status and things of the sort. So what is your next step? This is like somewhat being deprecated. So I would look at OneFuzz. It's a self-hosted fuzzing service as a platform. Definitely do go and peruse this one. Once again, it's Microsoft OneFuzz here, and it is self-hosted fuzzing as a service platform. And you'll see here with a single command, which can be baked in a CI/CD, developers can launch fuzz jobs with a few virtual machines to 1,000 cores. And I believe you can bring in your own fuzzers. So here we go, swap instrumentation, manage seed inputs. onboard your own fuzzer. So definitely I would lean at taking a look at this project here and seeing if it can aid you with your CI/CD needs. For me, the number one thing when I evaluate any tool is, can it integrate with, for example, Azure DevOps or GitHub, and can it send me messaging in Microsoft Teams? There's some notification callbacks. So that is excellent and very welcome. So on that, I'd like to thank you for your time today. Wanted to do a lightning talk, 30 minutes, very condensed talk on a complex subject, but at least this has gotten you to see the execution of RESTler, to see that you can go get it from GitHub, put it on your desktop, compile it. It's command line, so you're going to be executing it through the command line. You see the type of class of bugs that it's hunting for. You see which way you can utilize in its CI/CD chain. There's one tool being deprecated and one tool that is emerging. So best of luck in your utilization. Happy fuzzing, and on behalf of Bid and myself, thank you very much. And today from very snowy and dark Canada. So thank you very much. This is Joël Hébert, wishing you also a happy 2022 end of year. Ciao.